Okay. Afternoon. So the today's topic is hydraulic fundamentals. After ng pneumatics, dito tayo sa hydraulics. Oil ang medium dito. So basic hydraulics. The operation of a typical fluid power system is illustrated in figure 1. Ito yung oil mo. So pipilter mo siya para mag-circulate ipapump mo. Driving means it's either motor, couple, and pressure control. Then the direction niya, unidirectional control, one way. So, ito naman yung dinadrive mo. Okay? Connection. So, dinadrive mo piston. Horizontal. Forward, backward. So, pwede rin siyang rotary. So, convert mo na sa rotary yung movement. And return yung oil, functional control. Later, definition, directional control. Connect dito. System, simple diagram. An electric motor, air motor, gas, or steam turbine, or an internal combustion engine can drive the pumps without driving means. The pump increases the pressure of oil. The actual pressure developed depends on the design of the system. Okay? So, use of hydraulics. The hydraulic press, invented by an Englishman, Chan Brahma, was one of the first workable machines that used hydraulics in its operation. It consisted of a plunger pump pipe to a larger cylinder and a ram. This press found wide use in England because it provides a more effective and economical means of applying large uniform forces in industrial uses of industrial revolution. Today, hydraulic power is used to operate many different tools and mechanisms. So, operation of hydraulic components, factual diagram. To transmit and control power through pressurized fluid, sa figure, tingin kaya, such arrangement is commonly referred to as a system. The number and arrangement of the components vary from system to system, depending on the particular applications. In main applications, one main system supplies power to several subsystems, which are sometimes referred to as circuit. Basic lang tayo, ha? 7 basic components must be in hydraulic system. These basic components are 1, yung receiver, hydraulic pump, control valves, actuating devices, relief valves, lines, siyempre yung pipe tubing, so flexible hose, and the fluid, hydraulic fluid. Now, start with reservoir or receiver, the next hydraulic pump. For receiver or reservoir, this is usually a closed tank or vessel that holds the volume of fluid required supporting the system. The vessel normally provides several functions in addition to holding fluid reserve. The major functions include filtration of the fluid, heat dissipation, and water separation. Next, the hydraulic pump uses the energy source for hydraulic system. It converts electrical energy into dynamic hydraulic pressure. In almost all cases, hydraulic systems utilize positive displacement pump as their primary source. These are broken down into two primary subclassifications, the constant volume or the variable volume. Next, control valves. The energy generated by the hydraulic pump must be directed and controlled so that the energy can be used. A variety of directional and functional control valves are designed to provide a wide range of control function. Next is the actuating device. The actuators, damper actuators, sample lang yun. So the energy, ito yung ginagamit sa mechanical. The energy, mechanical equipment. The energy with the hydraulic system is of no value until it is converted to work. Typically, this is accomplished by using an actuating device of some type. This actuating device may be a cylinder, which converts the hydraulic energy into linear mechanical force. A hydraulic motor that converts energy into rotational force, yung sabi ko, rotation, or a variety of other actuators designed to provide a specific work function. Relief valve. A relief valve is always installed downstream of the hydraulic valve ito, so pwede itong pressure control, and to provide a pressure relief should a problem develop within the system. So the relief valve is designed to open at preset system pressure. When the valve opens, it diverts flow to the receiver tank or reservoir. Yan, balik dito. Line, the pipe, tubing, or the flexible nozzles. All systems require some means to transmit hydraulic fluid from one component to another. So the material of the connecting lines will vary from system to system or within the system. Hydraulic fluid. The fluid provides the vehicle that transmits input power, such as from hydraulic pump to the actuator device or devices that perform work. So yeah, this is an hydraulic oil lang. Hydraulic pumps. The purpose of a hydraulic pump is to supply the flow of fluid required by a hydraulic system. The pump does not create system pressure. System pressure is created by a combination of flow generated by the pump and the resistance to flow created by friction and displacement within the system. Operation. A pump must have a continuous supply of fluid available to its inlet port before it can supply fluid to the system. As the pump forces fluid through the outlet port, a partial vacuum or low pressure area is created at the inlet port. When the pressure at the inlet port is lower than the atmospheric pressure acting on the fluid in the reservoir must force the fluid into the pump inlet. This is called a suction lift condition. Performance. Pumps are normally rated by their volumetric output and discharge pressure. The volumetric output is the amount of fluid a pump can deliver to its outlet in a certain period of time and at a given speed. Volumetric output is usually expressed in gallons per minute or GPM. Since changes in pump speed affect volumetric output, some pumps are rated by their displacement. Pump displacement is the amount of fluid the pump can deliver per cycle for all complete rotation. Since most pumps use a rotary drive, displacement is usually expressed in terms of cubic inches per revolution. Hydraulic fluids. Selection and care of hydraulic fluid for a machine will have an important effect on how it performs and on the life of hydraulic component. During the design of the equipment that requires fluid power, many factors are considered in selecting the type of system to be used. We have the hydraulic, pneumatic, or combination of the two. Some of the factors required are speed and accuracy of operation, surrounding atmospheric conditions, economic conditions, availability of replacement fluid, required pressure level, operating temperature range, contamination possibilities, cost of transmission lines, limitations of the equipment, lubricity, safety to the operators, and expected service life of the equipment. Purpose of the fluid. Dito, we have the lubrication, sealing, and cooling. Ito yung sa lubrication. Check na. Ito naman sa cooling coil. The fluid lubricates working parts. The 3, circulating oil cools the system. Ito, this. Nandito yung shading. So properties. The most important properties and some characteristics are the density, the specific gravity, the viscosity. We have the absolute viscosity, kinematic viscosity, SUS, SI number. And next, viscosity index, the 4-point aggregating power, chemical stability, freedom from acidity, +point, 5-point, minimum toxicity, compressibility, forming tendencies, and cleanliness. Yung mga definition nitong 4-point, alaman nyo. +point, 5-point, kasi lumalabas sa board exam at napalabas yun din natin dito sa exam natin dito. So, itong topic na mention, so natin yung definition. Mostly sa reviewer. Contamination. So, hydraulic fluid contamination may be described as any foreign material or substance whose presence in the fluid is capable of adversely affecting system performance or reliability. Filters will provide adequate control of the particular contamination problem during all normal hydraulic system operations. If the filtration system is installed properly, then the filter maintenance is performed properly. Filter maintenance includes changing elements at proper interval. Hydraulic fluid sampling. So the condition of hydraulic system as well as its probable future performance can be best by analyzing the operating fluid. Of particular interest are any changes in physical and chemical properties of the fluid and excessive particulate or water contamination, either of which indicates impending trouble. Next, the reservoir, strainers, filters, and accumulators. Fluid power system must have a sufficient continuous supply of uncontaminated fluid to operate efficiency. Hydraulic reservoirs, various types of strainers and filters, and accumulators are typically installed in fluid power system. So this is the reservoir. Yan, sura niya. Non-pressurized reservoir. Kasi meron siyang LP there. So, isa pressurized. Okay. A hydraulic system must have a reserve of fluid in addition to that contained in the pump, actuators, pipes, and other components of the system. This reserve fluid must be readily available to make up losses of fluid from the system, to make up for compression of fluid under pressure, and to compensate for the loss of volume as the fluid moves. This extra fluid is contained in a tank usually called a reservoir. A reservoir may sometimes be referred to as sump tank, service tank, operating tank, supply tank, or base tank. Most reservoirs have a cap opening for filling, an air vent, an oil level indicator or dipstick, a return line connection, a pump inlet or suction line connection, a drain connection, and a drain tank. So see figure 5. Accumulators is a pressure storage reservoir in which hydraulic fluid is stored under pressure from external source. The storage of fluid under pressure serves several purposes in hydraulic system. After the pump, kailangan ng accumulator. Accumulators also compensate for thermal expansion and contraction of the liquid due to variation in temperature or generated heat. Filtration. So, may filter na naman tayo dito. Filtration devices are installed at key points in fluid power system to remove the contaminants that enter the system along with those that are generated during normal operations of the system. The filtering devices used in hydraulic system are commonly referred to as strainers and filters. Since they share a common function, the terms are often used interchangeably. In general, devices used to remove large particles of foreign matter from hydraulic system are referred to as strainer, while those used to remove smallest particles are filters. So strainers are primarily used to catch only very large particle and rarely found in application where this type of protection is required. The most common device installed in hydraulic system to prevent foreign particles and contaminants from remaining in the system are referred to as filters. Now, filter element. Yung filter is assembly yan. Sa loob, meron siyang elements, which is maybe divided into two classes, the surface and deep filter. Nakakita niyo kayo niyan, search na sa internet. Surface filter are made of closely woven fabric or treated paper with a uniform pore size. Yung parang binalot lang. Fluid flows through the pores of the filter material and contaminants are scrubbed on the filter surface. This type of filter element is designed to prevent the passage of high percentage of solid of a specific size. Deep filters, on the other hand, are composed of layers of fabric or fibers, which provides many tortuous paths for the fluid to flow through. The pores or passages must be larger than the rated size of the filter if particles are to be retained in depth of the media rather than on the surface. So yan, pagkaiba niya. The filters, ibig sabihin yung marami sa balot. Filter elements may be of the 5-micron, woven mesh, micronic, porous metal, or magnetic type. So, ibang discussion na ng filters filtration. So, the micronic and 5 microns have non-cleanable filter media and are disposed of when they are removed. So, tapon na. Porous metal, woven mesh, and magnetic filter element are usually designed to be cleaned and reused. Heat exchangers, yan. So, minsan meron yan. The conversion of hydraulic force to mechanical work generates excessive heat. This heat must be removed from hydraulic fluid to prevent degradation of the fluid and possible damage to system components. Heat goes into the hydraulic oil, yung fluid, at every point in the system where there is a pressure loss due to oil flow without mechanical work being produced. Examples are pressure relief and reducing valves, flow control valves, and flow resistance in plumbing lines and through component. Hydraulic pumps and motor also produce heat at about 15% of their working horsepower. Parang yun na yung estimate. Actuators. So, ito mga actuators. An actuator is a device that convert fluid power into mechanical force and motion. So, the most common type of actuating device, cylinders, hydraulic motors, and turbines are the most common types of actuating devices used in fluid power system. So, unahin natin yung hydraulic cylinder. Hydraulic cylinder. An hydraulic actuating cylinder is a device that converts fluid power into linear or straight line force and motion. Since linear motion is back and forth motion along a straight line, this type of actuator is sometimes referred to as a reciprocating or linear motor. The cylinder consists of a ram or piston operating with a cylindrical bore. So ito yung piston rod, column length, strength. So ano yung, siyempre yung cylinder mo, merong rod. Ano yung size? Long, slim piston rod may buckle if subjected to heavy push load. So table 1 suggests the minimum diameter piston rod to use under various conditions of load in unsupported rod length. There must be no side load or bending stress at any point along the piston rod. So kung any load, 5 tons, so ang length ng rod mo is exposed, hindi nakabaon sa piston rod, sa piston. So yan. Kung 20 inches, so that ang required mo sa 5 tons mong load is 1 and 1. Example lang yan. This is, so itong table na to, magiging reference niya later sa pagtrabaho niya. Hydraulic cylinder forces. Ito nako-compute to. Okay. Table 2 and 3 provide the mechanical forces, both extension and retraction, that can be generated by hydraulic cylinder. The tables are divided into two principal operating pressure ranges associated with hydraulic application. So this is the hydraulic cylinder force, table 2, low pressure range 500 to 1,500 PSI. Okay, sa hydraulics, ang pressure nyo is not nag-rise na ganito ng 3,000, 5,000, matataas. So, ito yung bore, inch diameter, ito yung rod. So, ito yung 500 affected area. Pag wala siyang piston rod, so ito, so size, merong side kasi na yung isang side walang rod, piston rod. Yung isang side meron. So, ito yung merong piston rod ng affected area. So, yung area ng circle minus yung circle ng diameter 1 and 1 half minus 5/8 na area ng rod. So, ang force mo doon, siyempre multiply mo ng 500, lalabas ito. Okay. So, yun. Ito naman, sa 2,000 to 5,000 PSI. Then, mga standard size. Yan. So, continuation. Next is next to cylinder is the hydraulic motors. A fluid power motor is a device that converts fluid power energy into rotary motion and force. The function of a motor is opposite that of a pump. However, the design and operation of fluid power motors are very similar to pump. Therefore, a thorough knowledge of pump will help you understand the operation of fluid power motors. Next is the mga control valve. Valves are classified and intended by their intended use. Flow control valve, flow, pressure control, pressure, and direction control, direction. Some valves have multiple functions that fall into more than one classification. Okay, so flow control valves are used to regulate the flow of fluids. Control of flow in hydraulic system is critical because the rate of movement of the fluid power machines or actuator depends on the rate of flow of the pressurized fluid. Next, the lip valves are automatic valves used on system lines in equipment to prevent overpressurization. Most relief valves simply open at a pressure and shut when the pressure returns to normal limits. They do not maintain flow or pressure at a given amount, but prevent pressure from rising above a specified level. Pressure control. Okay. So, ito yung settings mo. Figure 4, ito, shows a typical relief valve. System pressure simply act under the valve. This at the inlet of the valve. When the system pressure exceeds the preload force set by the valve spring, the valve this will lift off its seat. So this allows some of the system fluid to escape to the valve outlet. So the flow will continue until the system pressure is reduced to level below the spring force. So pressure regulators, ito naman, figure 5, often referred to as unloading valve, are used in fluid power system to regulate pressure. In hydraulic system, the pressure regulator is used to unload the pump and to maintain or regulate system pressure at desired value. So many systems are equipped with variable displacement pump which contain a pressure regulating device. Ito yung mga parts niya. So pressure regulators are made in a variety of types. However, basic operating principles of all regulators are similar to what is illustrated by figure 5. So A, B, C, and yung flow. High pressure line, tapos open, so back naman dito. So study this. So in summary, when the system pressure decreases, the pressure regulator will open, sending up to the system. When the system pressure increases, the regulator will close, allowing the fluid from the pump to flow to the regulator and back to the reservoir. The pressure regulator takes the load up the pump and regulates the system pressure. Sequence valve. Ito naman. Importante ito pag may kaya. Step 1, step 2, step 3. Sequence valve control the sequence of operation between two branches in a hydraulic circuit. Stage 1, stage 2, stage 3. In other words, they enable one component within the system to automatically set another component into motion. A sequence valve is somewhat similar to relief valve, except that after the set pressure has been reached, the sequence valve diverts the fluid to a second actuator or motor to do work in another part of the system. So figure 6 shows an installation of two sequence valves that control the sequence of operation of three actuating cylinder. Fluid is free to flow into cylinder A. The first sequence valve 1 blocks the passage of fluid until the piston in cylinder A moves to the end of its stroke. At this time, sequence valve 1 opens, allowing the fluid to enter cylinder B. This action continues until all three pistons complete the stroke. Next is the pressure reducing valve. Ito yung pressure control. Ito naman nag-reduce. Pressure reducing valve provide steady pressure into a part of the system that operates at a pressure lower than that normal system pressure. A reducing valve can normally be set for any desired downstream pressure within its design limit. Once the valve is set, the reduced pressure will maintain regardless of changes in the supply pressure and system load variation. Next is the directional control valve. These are designed to direct the flow of fluid at the desired time to the point in a fluid power system where it will do work. Various other terms are used to identify directional valve, such as selector valve, transfer valve, and simply control valve. Directional control valve may be classified in several ways. Some of the different ways are by type of control, the number of ports and valve housing, and the specific function that valve performs. Ito yung makikita nyo sa mga hydraulic symbols, di ba? The most common method is by the type of valving element used in the construction of the valve. The most common type of valving element are the bowl, cone, sleeve, puppet, rotary spool, and sliding spool. So next, the lines in fittings and seals. So the control and application of fluid power would be impossible without suitable means of transferring the hydraulic fluid from the reservoir to the power source and the points of application. Fluid lines are used to transfer the hydraulic fluid. Fittings are used to connect lines to system components. And seals are used in all components to prevent leakage. So the three types of lines are used in fluid power system. We have the pipe, which is rigid, tubing, which is semi-rigid kasi na-bend mo siya, and hoses, flexible. Yan, talagang mapaikot siya. Rule. So a number of factors are considered when the type of line is selected for a particular application. These factors include the type of fluid, the required system pressure, and the location of the system. So yung pipe and tubing, selection and sizing. So pipe and tubing, so there are three important dimensions of any tubular product. We have the outside dimension, inside dimension, diameter, and wall thickness. Sizes of pipe are listed by nomina or approximate ID and the wall thickness. Approximate ID yun. The actual OD and wall thicknesses list sizes of tubing. Iba yung sa tubing. Mga copper, yan. Ang nominal niya is actual OD. So sa pipe, alam nyo naman yung schedule, pipe size, nominal pipe size. Selection. So the material, inside diameter, ID, and wall thickness are the three primary consideration in the selection of lines for a particular fluid power system. The ID of the line is important because it determines how much fluid can pass through the line without loss of power due to excessive friction heat. So velocity. Pipes are available in three different ways: the standard or schedule 40, extra long or schedule 80, double extra long, schedule 160, wall thickness is double extra strong. So iba yun sa schedule 160. Schedule 160 wall thickness is slightly thinner than the double extra strong. Ngayon, ang ginagamit natin is yung schedule 40, 80, and 160. Next, tubing differs from pipe in its classification. Its actual outside diameter, that is OD, designates that tubing. That a 5/8 tubing has an OD of 5/8 as indicated in table 6. So as in table 6. So table 6, wait. Okay. So tubing, yung table 6 na sa reference book. Nalis ko na lang dito. Saka doon sa Word file nito, check dito kasi mas mahaba yung discussion na. Ito kasi nung page to page, masyado mahaba. So tinanggal ko yung iba. Doon na lang yung basahin sa sa Word file. Naka namang lahat yun. Display. Diba? So, ang important parts lang dito. So, ayan. Tubing is available in variety of wall thickness. 7/8, 1/8, 1/2, 3/4. Yan. The diameter of tubing is often measured and indicated in 1/16. Thus, number 6 is 6/16 or 3/8 inch or D. Number 8 is 8/16 or 1/2 inch. So forth. Materials. So the pipe and tubing used in fluid power system are commonly made of steel, copper, brass, aluminum, and stainless steel. Each of these metal has its distinct advantages and disadvantages in certain applications. Not steel pipe, ito yung may schedule 40. Copper, brass, aluminum, stainless, tubing yan. So preparation, fluid power system are designed as compactly as possible to keep the connecting line short. So iwas fittings, minimize. Every section of line should be anchored securely in one or more places so that neither the weight of the line nor the effect of vibration are carried on the joint. Kaya nga maiksi lang yan, matipid na system lang yan. The aim is to minimize stress throughout the system. Lines should be kept normally as short and free of bend as possible. However, tubing should not be assembled in a straight line because a bend tends to eliminate strength by absorbing vibration and compensate for thermal expansion and contraction. Bends are prepared to elbows because bend cause less loss of power. Bend, palututin mo lang. Bends are described by their radius measurement. So the ideal bend radius is 2.5 to 3 times the ID. Di ba nag-bend ka ng tubo? So yan ang guide niya. Pag masyadong ano yung bend radius mo, so mag-oval yun, nayuyupik. So for example, if the ID of a line is 2 inches, the radius of the bend should be between 5 to 6 inches. Haba pa yan. So tube cutting and deburring. So the objective of cutting tubing is to produce a square end that is free from bars. Tubing may be cut by a standard tube cutter. So hindi ko napakita doon. Doon sa reference, may mga picture to. And fine tooth hacksaw. Maraming masama discussion dito. Tube bending and tearing, ganito rin, may mga drawing pa to, procedure. The objective in tube bending is to obtain a smooth bend without flattening the tube. Tube bending is usually done with either hand tube bender or mechanically operated bender. Tube flaring is a method of forming the end of a tube into a funnel shape so a threaded fitting can hold it. When a flare tube is prepared, a flare nut is slipped into the tube and the end of the tube is flared. So, check na siya, libro na. During the tube installation, the flare is seated to a fitting with the inside of the flare against the cone-shaped end of the fitting, pulling the inside of the flare against the seating surface of the fitting. So, check nyo doon ha. So, reference o kaya reference nyo. May mga procedure to ng cutting na drawing doon. Flexible hose. Shock resistance flexible hose assemblies are required to absorb the movement of mounted equipment under both normal operating conditions and extreme conditions. They are also used for their noise attenuating properties and to connect moving parts of certain equipment. The two basic host types are synthetic rubber and polytetrafluoroethylene (PTFE), such as DuPont's Teflon fluorocarbon resin. So rubber hoses are designed for a specific fluid, temperature, and pressure ranges and are provided in various specification. Yan, may specify yan. Sa tube na may mga nakalagay doon. Pressure, temperature. So size and curing date. The size of flexible hose is identified by the dash number, which is the ID of the hose expressed in 16th of an inch. For example, the ID of a dash 64 hose is 4 inches. For a hose style, this is the normal. This is the nominal and not true ID. For a few hose style, so meron naman ganun. So synthetic rubber hoses will deteriorate. Synthetic rubber hoses will deteriorate from aging. A cure date is used to ensure that they do not deteriorate beyond material and performance specification. So the cure date is the quarter and year the hose was manufactured. For example, 1Q89 or 1/89 means the hose was made during the first quarter of 1989. Manufactured na, hindi yung binili, hindi yung pagkabit. So, the cure date limits the length of time a rubber hose can safely use in fluid power application. So, the normal shelf life of rubber hose is 4 years. So, types of fittings and connectors. Doon sa ano reference, maraming picture. Hindi ko na dito kasi nung unang ginawa ko ito, masyadong mahaba. Nag-2 meetings kami dahil doon sa mga figure na yun. So, i-check na lang. Some type of connectors or fitting must be provided to attach the line to the component of the system and to connect sections of line to each other. There are many different types of connector and fittings provided for this purposes. The type of connector or fitting required for a specific system depends on several factors. One determining factor is the type of fluid line, pipe, tubing, or flexible used in the system. Other determining factors are the type of fluid medium and maximum operating pressure of the system. Next is the pipes and tubings. High pressure pipe or tubing can also be used for hydraulic circuits. In this application, special threading or fittings are required to connect circuit components. High pressure. So, threaded connectors and flange type. So, there are several different types of threaded connector. Both connectors and the end of the fluid line are threaded. These connectors are used in some low-pressure fluid power system and are usually made of steel, copper, and brass. Is available in variety of design, male to female, for example. Voltage flange connector are suitable for most pressure now in use. The flanges are attached to the piping by welding, bracing, tapered sides, or rolling and bending into recesses. So for the welded and braced, welded joints connect the sub-assemblies of some fluid power system, especially in high-pressure system that use pipe or fluid line. The welding is done according to standard specification that define the materials and strength. Silver brace connectors are commonly used for joining non-ferrous piping and steel in the pressure and temperature range where their use is practical. Use of this type of connector is limited to installation in which the piping temperature will not exceed 425 Fahrenheit and the pressure in full lines will not exceed 3000 psi. Heating the joint with an oxyacetylene torch melts the alloy. This causes the alloy insert to melt and fill the few thousand of an inch angular space between the pipe and heating. Third, sa mga may flaring tools. Flared connectors are commonly used in fluid power system containing lines made of tubing. This connector provides safe, strong, dependable connection without the need for threading, welding, or soldering the tubing. The connector consists of a fitting, a sleeve, and a nut. Now next is the connectors for flexible hose. There are various types of end fittings for both piping connection side and hose connection side of hose fitting. Sa reference nga, ito naman, flexible, ang dami-dami niya type. Picture doon. quick disconnect coupling. Ito rin. Self-sealing quick disconnect coupling are used at various points in many fluid power systems. These coupling are installed at locations where frequent uncoupling of the line is required for inspection, test, and maintenance. Last is the manifold. A manifold is a fluid conductor that provides multiple connection ports. Yan. Isa lang yan na maraming butas. Manifold eliminate piping, reduce joint, which are open source of leakage and conserve space. Okay? So, wala tayong mga picture dito kasi kusa sa oras. This is the end of hydraulics fundamental.